Welcome. Global cooling. We've been hearing a lot about it recently, but I contend, in the words of Shakespeare, that it's much ado about nothing. And in this video, I'm going to show you why I believe that. What got my attention on this matter was the fact that somebody put great big headlines on a YouTube channel that global temperatures were plummeting. They showed this plot from the University of Alabama, Huntsville, and they showed that the October temperature, marked here at the top, versus the November temperature was a whole 0.3 of a degree centigrade down. So the Earth was clearly cooling. But if you look back at some of this older data, you see there's as larger excursions, both positive and negative, throughout the history of this data. And even so, the general trend is still upwards, i.e. it's a warming trend. Here I have plotted the same data as was shown in the previous graph, and I've added the best fit trend line to the data, which shows a generally positive increase over that period of time, even including this latest point. Can we quantify this month-to-month variability to see whether this drop over the last month is significant? Well, yes, we can. We can determine the standard deviation of this data from the mean, and that's 1 sigma, shown here on the right. And 1 standard deviation of this data is equivalent to 0.14 degrees centigrade, plus or minus. So that's the error bar that I've shown on the right there. And as you can see, this drop in temperature is about 1 sigma. But 1 sigma is not very significant. The chance of it being significant is 68%, barely more than a coin toss. Normally in science, we go to 2 or 3 sigma before we consider something is significant, and this is far short of that. What concerns me here is that by looking at the full data set like that, you're comparing apples and oranges. You're comparing the month of October to the month of November. Perhaps we should be comparing the Novembers for the previous umpteen years. And this is what this plot is. There are 2 versions of this plot, one from UAH and the other one for remote sensing systems. So if we compare November's only, we're removing the annual variability. We're just looking at what's happening in the month of November over the last 40 years. These 2 groups, UAH and RSS, have slightly different methods. They use different atmospheric models to produce their data. UAH shows a slight cooling since last November. That's in blue on the right there. Whereas RSS shows a slight warming in red on the right there. So who are we to believe? Some things to note. Satellites do not measure temperature. They measure effective temperature. They require atmospheric models to derive an effective temperature from the infrared data that they gather. They first of all average over a large volume of the atmosphere. That's why they need the models. And the lower troposphere data, which is what we're looking at the moment, averages an altitude of about 4 kilometers. So this is quite a way up in the atmosphere, and it's a lot cooler up there. So they don't measure surface temperature. Now, you've got to remember that. You can't compare these data to the thermometer record, which is often a trick that some of these folks do. The other thing to note is because this is a very computationally intense process, there's been a lot of errors noted in these data in the past. So how much do you trust it even now is the question. There are outside factors affecting these measurements as well. At the moment, we're in a strong La Nina, which means a large portion of the Eastern Pacific is cooler than average. You can see this here just off the coast of South America. There's this long finger of blue, which is indicating cold sea surface temperatures stretching almost to Australia. Another factor is we've had some major eruptions this last year, which tends to cool the troposphere. There's been La Palma, Iceland, Indonesia, and many other possible eruptions that have affected the temperature of the troposphere. So you might expect it to not be warming very much or even cooling slightly as a result of that. But that doesn't mean the whole planet is cooling. So what conclusions can we draw from all of this? First of all, the Earth as a whole is not cooling. Some are making a big deal over insignificant month-to-month variability. Statistical fluctuations do not determine long-term trends, and the long-term trend, even at these high altitudes, is still a warming one of about 0.14 degrees centigrade per decade. not too different from what the surface thermometers give, slightly lower but very similar. So let's take a look at this in graphical terms. On the left here we have a map generated by NASA of what the global temperatures were for the late 19th century compared to the average of the 20th century. And you can see most of the globe was a lot cooler than it is now, or was then, I should say. On the right, we have what the situation is at the moment, and you can see most of the globe has warmed with respect to the 20th century and considerably compared with the 19th century. And so we can only conclude that the Earth is still warming, and quite rapidly. So until next time, stay safe and goodbye.